Hello, everyone. Welcome back. Today we're going to go through operations with scientific notation. All right, so we're first going to read this page about scientific notation and using operations to solve these equations, and then we're going to move on to actually doing so ourselves in part two. So let's take a look at addition and subtraction. So, how do we add things with scientific notation? Well, before numbers in scientific notation can be added or subtracted, the exponents must be equal. Now, why is that? That's because if the exponents are not equal, then the place values are not going to be the same, and we're going to get a completely incorrect answer. So you might notice that this 10 squared and this 10 cubed are not equal. So we actually have to change one of these out of scientific notation by moving this decimal place over to the left to increase the exponent. So this part here is no longer scientific notation, right? Because scientific notation is when we have just one digit to our left that isn't zero, right? And here now we don't have any, but that's okay. We had to do this in order to match this other one so we could add these two things, because overall we will still get an answer in scientific notation because the second thing we're adding is in scientific notation. So we end up right here where we do have something that is scientific notation where we have just one non-zero digit to the left. Okay, so that aside, we're going to switch these so that the exponents can be equal. Then we're going to factor out these two numbers, what we're adding, and we're going to add them together. When we add them together, we get 4.91, and then that's going to be times 10 to the power of 3. So there we have it. All we need to do to add these up is we need to move the decimal point to make sure the exponents are equal, and then we can add the two values together. Okay, now how about multiplication? When numbers are multiplied in scientific notation, only the number is multiplied, exponents are added, right? And this goes back to our exponent laws that we talked about previously, right? Where we mentioned that whenever we multiply two exponents together with the same base, we add up the exponents. So it makes sense. We're going to add up what is 10 cubed times 10 to the 4? Well, that's going to be 10 to the 7, right? 10 to the 3 plus 4. And then what else do? We multiply the regular numbers together, 4 times 2, and we say, well, that's 8. So basically, all we must do for this one is multiply these two numbers, we get 8, and then we multiply these two numbers, and we get 10 to the 7, because when we multiply two exponents with the same base, we add the exponents, right? Which is something we discussed previously. Good. Now, you might have already guessed, but division is similar to that, right? With division, what happens when we divide two exponents with the same base? We subtract the exponents. That's right. So we're going to be subtracting here 7 minus 4, and we're going to end up with 10 to the power of 3. And then we'll just do regular division with our calculator for 9.6 divide by 1.60, right? So, and just like it says, when we divide exponents, the exponents are subtracted. So we end up with 6, because 9.6 over 1.6 is just 6. And then 10 to the power of 3, right? Because we're subtracting the 7 and the 4. So 7 minus 4 gives us to 3. Okay. So now I'm going to go through some more examples because I realize this page kind of just gives us one example of each, which is a good start, but we would like to do some more examples. So let's start with adding and subtracting, and then we'll get into multiplication and division. I actually think adding and subtracting is a harder one than multiplication and division. Maybe not harder, but more steps. So in that sense, maybe harder. Okay. So here it says, perform the following operations and express the answer in scientific notation. So the first thing I notice here is that we have 10 to the power of 5 and 10 to the power of 6, and those things are not equal. So we have to make them equal. And to do that, I'm going to move this decimal over to the left one, and then take away one of the powers of 10. right? Because again, going back to here, if we move our decimal point to the left, when we move the decimal point to the left, we get to add a power of 10. When we move the decimal point to the right, we get to take away a power of 10. So going back here, let's move this one to the left to here, and then let's add a power of 10 here. And that's something I want to point out that I missed on earlier, is that we always want to move the smaller power up to the larger power, so that way our answer is automatically in scientific notation when we get it, as opposed to our answer possibly not being scientific notation. Much more likely is going to be if we do it this way. So let's do that. So 1.2 times 10 to the power of 5 is the same as 0.12 times 10 to the power of 6. And then this next part just stays as is, 5.35 times 10 to the power of 6. Now my next step is I'm going to add up 0.12 plus 5.35, and that's times 10 to the power of 6. And then what happens when I actually add these? I'm going to get 5.47 times 10 to the power of 6, and that's my final answer there. Very good. Okay, let's try the second one. Here we have 6.91 times 10 to the negative 2 plus 2.4 times 10 to the negative 3. So for this one, which exponent is bigger? The 10 to the negative 2 is bigger, right? These are negative numbers, and so negative 2 is a larger number than negative 3. They're both negative, right? They're both in the negative section, but negative 2 is not as far negative as negative 3. So actually, in this case, negative 3 is the smaller exponent, okay? And so that's the exponent we're going to add 1 to by going to the left, right? So I'm just going to repeat this first point and just put it back. And then for that second one, I'm going to move the decimal point over and get 0.24 times 10 to the negative 2. Right? So what we did here is we went left a decimal point, but we evened it out. We balanced that out by adding a power of 10 back. So now we're only at 10 to the negative 2 rather than 10 to the negative 3. Okay, now I'm going to add up my values. 6.91 plus 0.24 times 10 to the negative 2. Okay, so that now the next question we have to ask ourselves is, what is 6.91 plus 0.24? That's going to be 7.15. So the final answer is 7.15 times 10 to the negative 2. All right, let's try the next one. Same kind of thing. Which one do we want to switch over? It's the one with the smaller exponent. We're going to bring it up to the larger exponent. So that's going to be 8.3 times 10 to the power of 5, right? Because the other one is to the power of 6. So I'm going to rewrite this as 9.7 times 10 to the 6 plus 0.83, right? I moved it one left, and I'm also going to be able to then go up a power of 10. So times 10 to the power of 6. Now I'm going to add these numbers up. So 9.7 plus 0.83 times 10 to the power of 6. Okay, and then we have 9.7 plus 0.83. So that's going to be 10.53 times 10 to the power of 6. Very good. Okay. All right, here's our next one. This one, the lower power is 10 to the power of 1, right? We have 10 to the 2 and 10 to the 1. So the lowest is 10 to the power of 1. So I'm going to raise that power up to 10 squared. So we're going to have 3.67 times 10 squared minus 0.16 times 10 squared, right? I moved my decimal point one to the left and I added a power of 10 on. Now we're going to subtract. So 3.67 minus 0.16 times 10 squared. And then what is 3.67 minus 0.16? Well, that's going to be 3.51 times 10 squared. And there's our answer. Okay, now let's do letter E. So which one of these exponents is smaller? Is it 10 to the negative 5 or 10 to the negative 6? Well, actually, 10 to the negative 6 is smaller, right? So for this one, it's going to be 8.41 times 10 to the negative 5 minus 0.79 times 10 to the negative 5, right? So I added a power of 10 back in, and I moved my decimal point one to the left to get 0.79 rather than 7.9. And now I will subtract. So we have 8.41 minus 0.79 times 10 to the negative 5. And what's that going to end up being? Well, let's see. 8.41 minus 0.79 equals 7.62. Ooh, let's do a nicer 6. 7.62 times 10 to the negative 5. And there we go. Okay. Next, let's move on to letter F. So F is, we have 10 to the 5 and 10 to the 4. So we need to change the 10 to the power of 4 and make it a 10 to the power of 5. And how do we do that? We move our decimal place one to the left. So let's do it. We have 1.33 times 10 to the power of 5 minus, let's see, 0.49 times 10 to the power of 5. Then we'll do 1.33 minus 0.49 times 10 to the 5. And let's put that in. So that's 0.84 times 10 to the power of 5. Now, there's one thing I notice here that isn't very common. It didn't happen for any of these other ones. It doesn't look like. Oh, actually, it did. I will address that in a minute for C. Most of these other ones, we ended up with scientific notation automatically in most cases. But in this case, we got 0.84 times 10 to the 5, which is not scientific notation. We have to move the decimal place right once to get to scientific notation. So I'm going to do that and make this 8.4 times 10 to the power of 4. And then there's actually one other time it happened that I missed earlier, which is in C. We got 10.53. Well, that's two decimal points that are to the left of our, that's two digits that are to the left of our decimal point that aren't just, extra zeros on the far left, right? That 10, this 0, it has meaning to it, right? It's a placeholder there. So this one we could say is the same as 1.053 times 10 to the power of 7. So always bringing it up to the highest, the higher power of the two. Most of the time it's going to automatically give you scientific notation, so that's the way I suggest doing it. But also do check, unlike what I did here where I didn't check, to make sure that your end product is scientific notation as well. Most times it will be, right? Now, if you don't know what is or isn't scientific notation, do make sure you go watch that lecture video to figure it out. But the long and short of it is, the short version is, scientific notation is when we have just one non-zero digit, other than, not including a placeholder to 0 digit, that's okay. But, just one regular digit to the left of the decimal point, and then everything else is to the right of the decimal point. That's the key factor for what is or isn't scientific notation in terms of, what's the short answer to that question. There it is. Okay. Now let's move on to part 2, where it says perform the following operations and express the answers in scientific notation. So what do we do for A? What I'm going to do is I'm going to multiply 4.3 times 2, which 4.3 times 2 is going to be 8.6, right? So 8.6. And then we have 10 to the power of 8 times 10 to the power of 6, which, as we know, when we multiply exponents together with the same base, what do? We add the exponents. So we're going to end up getting times 10 to the power of 14. And yes, this is scientific notation, right? We just have one decimal point to the left, or one digit to the left of our decimal, right? And everything else is on the right, which happens to only be one digit in this case anyway. All right, how about this one? It's 6 times 1.5. Well, what is 6 times 1.5? Well, that's the same as 3 times 3, which is 9. So it would be 9 and then times 10 to the power of 1. Okay. And now, why is it 10 to the power of 1? Well, if we add the exponents of 3 and negative 2, 3 plus negative 2 is 3 minus 2, which is 1. So therefore, it would be 9 times 10 to the power of 1, which actually is just 90, right, if we think about it. But it did say to express the answer scientific notation. So I will do so here because that's what was asked, even though 90 seems like actually a better way to express this one. All right, what about C? We have 1.5 times 8. So 1.5 times 8 would be 12. So 12. And then times, let's see, 10 to the negative 2 times 10 to the negative 1 would be 10 to the power of negative 3 if we add negative 2 and 1 together, or a negative 1 together. Now, this is not scientific notation because the decimal point would be here, right? And so we would have to move the decimal point 1 to our left in order to get this to be scientific notation. So it would have to look like 1.2 times 10 to the something. Now, what do we need to do to our exponent? If we move our decimal point to the left, we need to multiply by 10 again. So therefore, it would just be 10 to the minus 2 instead of 10 to the minus 3 because we are moving our decimal point 1 left. For this 9 up here, it's okay because our point would be here and we just have one digit to our left. But because 12 is a 2-digit number, it does not accurately express scientific notation until we move the decimal point and make it 1.2. Good. All right, let's try this one, D. This is 7.8 times 10 to the 10 cubed over 1.2 times 10 to the power of 4. Okay, so first of all, what is 7.8 divided by 1.2? Well, if we punch that in our calculator, we get 6.5. So I'll write 6.5. And then what do we get when we do 10 to the power of 3 minus, minus 4, right? Because again, when we divide our exponents with the same base, we subtract the exponent. So it would be 10 to the power of 3 minus 4, which is going to be 10 to the power of negative 1. Now, again, this one might be easier to just express this, as, you know, as 0.65. We could do that, but the question asks for scientific notation, so I will leave it as is for that reason, even though, yes, we could express this in maybe a more digestible manner without in this case. Okay. All right, how about this next one? We have 8.1 divided by 9. So if we punch that in our calculator, we're going to get 0.9. And then here we have 10 to the power of negative 2 on the top and 10 to the power of 2 on the bottom. So it would be times 10 to the power of negative 2 minus another 2. So this would be 0.9 times 10 to the power of negative 4. Now, is this scientific notation? Well, no, it isn't. The only digit we have on our left is a 0, right? This is just a 0. And so we need to move our decimal point 1 to the left so that we have one decimal point, we need to move the decimal point to the right so that we have one digit exactly on our left that is not, a 0. So that's how I'm going to do 9 times 10 to a new power. So when we move the decimal point right, we need to also, what are we doing essentially? We're multiplying by 10, right? An extra time. So that means it's going to be 10 to the power of negative 3. And there we go. There's our answer. Okay, now we have a complex one. What I'm actually going to do for this one is we're going to solve the bottom first, and then we're going to revisit the top. So I'm just going to keep the top the same for now. And let's solve for the bottom. So what's 2.4 times 1.8? Well, let's see. 2.4 times 1.8. If we punch that in our calculator, we get 4.32. And then what about 10 to the power of 4 times 10 to the negative 2? Well, again, when we multiply exponents with the same base, we add the exponents. So the question is, what's 4 plus negative 2? That's going to be 2. So it's times 10 squared. Now let's do the division. So what is 6.48 divided by 4.32? Well, according to the calculator, it's 1.5, which that is good. That is scientific notation worthy, so that's good. And then what do we need to do now? We need to subtract the exponents, right? When we're dividing, exponents with the same base, we subtract the exponents. So we have 10 to the power of 5 minus 2, which is 10 to the power of 3. And there we go. There's our answer. All right, well, that is it for scientific notation for today. I hope you learned a lot from this, and we will see you next day. Bye, everyone.